Okay, so kailan ba nagiging eccentric ang isang connection? Kasi yung previous discussion natin is simple connection. So dati, 'di ba, when we say simple connections, the load applied in the connection passes through the centroid of the group of bolts, rivets, or group of even welds. Kapag yung load passes through the centroid of the connections, that is considered as simple connection. When we say simple connections, direct shear lang siya. Ibig sabihin, the load is simply divided equally dun sa number of bolts, or kung weld siya, equally divided dun sa per unit length of the weld. Now, when it comes to eccentric connections, it is one in which the resultant of the applied loads does not pass through the center of gravity of the fasteners or welds. So the column bracket connection here shown is an example of bolted connection subjected to eccentric shear. So if you will look at the given figure, diba? So it has walong piraso ng bolts symmetrically placed and they're equally spaced. So by symmetry, by inspection, the center of gravity of these 8 pieces of bolt would be somewhere here. Okay, so dito yung centroid. And as you can see, the line of action of the load is here. Say that would be the line of action of the load. And obviously, the line of action of the load doesn't pass through the center of gravity of the connection. So there is an eccentricity. So this is the eccentricity E, the perpendicular distance. So whenever we have an eccentricity, that would be considered as eccentric connection. And of course, basic concept of eccentricity, diba, whenever we have eccentric load, katulad din sa beam column, well, let's say I have this member, tapos ito yung axis niya, tapos kunwari ito yung load, say P, with a distance of E, eccentricity E, measured from the center of gravity or of the centroid, diba, this could be analyzed by subdividing the effect of the eccentric load. So how? Diba, I could just copy this load P and put it at the center of gravity, say here. Lagay ko sa centroid P. Tapos kontrahin ko siya ng the same magnitude of P. Pataas naman. So in effect, wala akong dinadagdag, wala akong binabawas. Dinagdagan ko ng P pababa sa centroid. Tapos ikinontra ko rin siya ng P pataas. So in effect, wala akong dinadagdag dun sa system. So considering this P acting at the centroid, so ito siya. Nasa centroid. So ang tawag dyan is yung simple or direct shear. Simple connection or the direct shear. Tapos, if you consider naman ito, this P together with this P, diba, this is a couple. And that couple is actually P times the distance between them, the eccentricity E. And couple is a moment. And the direction of the couple based from this given example would be clockwise. Kasi yung P pababa na green, tas yung P na orange pataas. So that would induce a moment or a couple. So that would be times E. So this would be due to moment. So again, so this is eccentric shear that could be analyzed as direct shear plus moment. Okay, so direct shear plus moment. So ganyan din yung ginawa natin sa beam columns, 'di ba? So whenever we have an eccentric load, 'di ba yung sa example natin na ganito, ba ito yung section ng column. Kunwari, so this is the axis of the column. Tapos kunwari nandito yung load P. 'Di ba? So if that would be the load P, this is an eccentric load. So that could be the P compression plus bending. Tapos yung bending natin for this case is dalawa, no? Bending about X. Ito yung E about X. Tapos ito naman yung distance about y. No? So whenever we have an eccentric load, we could identify it as compression plus bending. So dito naman sa eccentric shear, compression means yung direct shear plus the moment. Okay, so remember this. Now, so going back to our slide, okay? So there we have the, for this example, so this is an eccentric shear. So again, what we are investigating or analyzing here is the shear strength of the connectors. So wala tayong pakialam, hindi natin muna concern yung strength ng connecting members, yung steel members. So yung pinaka ini-investigate natin dito are the connectors, the bolts, the rivets, or even the welds. Sila yung iniimbestigahan natin dito. And the nominal strength, P sub n, okay, so the nominal strength, P sub n, is actually equal to FNB times AB. FNB is the nominal shear strength. This is usually provided as a property of the given connector. No? So depende kung anong klaseng bolt or rivet yung gagamitin mo, basically this is given. And it could be found from the table shown last meeting, which was taken from the NSCP. Tapos yung A sub B, this is the cross-sectional area of the unthreaded part of the bolt, also known as the nominal bolt area or the nominal body area. Basically, that would be the pi over 4 diameter square, wherein diameter is the diameter of the bolt or rivet. Okay, so kasi yun yung nasi-sheared off na area for the part of the bolt. Bilog naman kasi yung cross-sectional area ng bolt, kaya pi over 4 diameter square. So pag na-common na yung nominal strength niya, Pn, just multiply it with the resistance factor P, which is 0.75. So you get the design strength. And as per LRFD, the design strength must be equal or greater than the P sub U. P sub U is the ultimate load that the connection carries. Then pagka sa LRFD naman, this is LRFD, no? Pagka ASD naman, Pn divided by the factor of safety or ohm should be greater than or equal to the P actual. And what is the safety factor for ASD for connection? If our resistance factor is 0.75, what would be the ohm value? O paano sinosolve yung safety factor? It's just the 1.5, diba sabi ko, yung resistance factor when multiplied with the ohm is always 1.5. So therefore, the ohm would just be equal to 1.5 divided by the resistance factor of 0.75. And that would be 2. So ang ohm natin for ASD is 2. So sa lahat ng discussions natin, very light ko lang ini-stress out or very light ko lang dinidiscuss yung ASD kasi most of the time, 'di ba, ang discussions na natin sa steel LRFD na. However, sa board exam, minsan kasi raw may lumalabas pa rin na mga ASD or combination ng ASD and LRFD. So basically, parehas lang naman yung method of solution natin for LRFD and ASD in such a way na ang common denominator nilang dalawa is yung determination ng P sub n, yung nominal strength. So nagkakaiba na lang sila dun sa pagkuha ng design strength ang tawag pagka LRFD, tapos allowable strength naman ang tawag sa ASD. Yung sa LRFD, yung design strength niya is yung Phi times Pn. Sa ASD, ang tawag dun sa Pn divided by ohm or yung Pn divided by the factor of safety, ang tawag dun is the allowable strength. So sa board exam, nagkakatalo lang sila kung anong gagamitin mo, ASD or LRFD, depende sa tanong. If the question is, what is the design strength? Pagka tinanong is design strength, LRFD na yon. Phi times Pn na yung solution. Pero if the question is, what is the allowable strength? Pag sinabing allowable strength, so ASD na yon. So that means the solution would be Pn over safety factor ohm. So doon lang nagkakatalo yung LRFD versus ASD. Okay? Pero common denominator nila is yung determination ng nominal strength P sub N. The rest are the same naman.